He was the last English king to die in battle, depicted by Shakespeare as a scheming hunchback.
In this case, by looking at the DNA of living individuals and comparing that with DNA samples.
Scientists had spent years poring over genealogical charts, archived chronicles, archaeological records, and the fragile remains unearthed beneath a nondescript parking lot in Leicester, but nothing prepared them for the revelations that emerged once they finally sequenced King Richard III's DNA. The discovery of his long-lost body had already captivated the world, yet the genome hidden within those centuries-old bones carried truths far more spectacular than anyone had predicted. What began as an attempt to confirm identity and ancestry quickly became an exploration that exposed hidden facets of medieval life, lineage, health, and the precarious politics of royal blood. As researchers extracted genetic fragments and assembled them into coherent strands, they uncovered a portrait of Richard that extended far beyond the well-worn narratives of history, reaching into the private biological details of a ruler whose life and death had been shaped by power, conflict, and myth-making. Before we start, smash the like and subscribe buttons for more updates. The sequencing revealed a surprisingly complex genetic heritage that challenged long-held assumptions about the medieval English monarchy. The royal family was often portrayed as a tightly confined lineage, its bonds reinforced through carefully arranged marriages and political alliances. Yet Richard's DNA told a different story. Hidden within the genome were markers suggesting a broader and more intricate web of ancestry than chroniclers had recorded. Subtle traces of continental European lineages threaded through his paternal and maternal lines, hinting at migrations, unions, and family histories that had left no trace in surviving documents. These findings upended the simplistic idea of an insular royal bloodline. They revealed instead a dynamic lineage shaped by centuries of movement across regions, influenced by shifting borders and cultural interactions that historians had often underestimated. One of the most striking aspects of the genetic analysis was its illumination of Richard's physical characteristics. Chroniclers and later storytellers had frequently described him in ways that served political purposes rather than historical accuracy. His enemies had painted him as deformed, malevolent, and twisted both in body and spirit, while his supporters emphasized dignity, capability, and noble bearing. DNA offered no allegiance to either narrative. Instead, it provided objective insight into traits such as hair color, eye color, and certain inherited predispositions. The data pointed to features that neither camp had ever fully captured, suggesting a man whose appearance was shaped not only by inherited traits, but also by environmental factors and the hardships of medieval life. Such revelations restored a measure of humanity to a figure often reduced to caricature. His genome helped strip away the distortions of propaganda, replacing them with scientifically grounded details that allowed a more authentic connection to the man behind the crown. The analysis also shed light on health conditions that had shaped Richard's life. While the skeletal remains had already revealed evidence of severe scoliosis, the genome suggested underlying genetic tendencies toward particular musculoskeletal vulnerabilities. These findings sparked intense fascination among medical historians, who sought to understand how such conditions might have influenced his physical endurance, posture, and daily challenges. Contrary to theatrical portrayals that exaggerated disability to depict villainy, the DNA suggested a more nuanced reality. Richard likely experienced significant discomfort and physical strain, yet his skeletal structure combined with genetic markers indicated a level of adaptation and resilience that belied depictions of frailty. Scientists noted patterns in his genome associated with metabolic efficiency, immune response, and injury recovery, implying that his body had been equipped with strengths that complemented his role as a military commander in an era defined by hand-to-hand combat. Perhaps the most provocative revelations emerged from analysis of supposed paternal lineage. For centuries, historians had accepted documented genealogical lines connecting Richard to earlier generations of English kings. Yet the DNA contained indicators that raised questions about the continuity of that lineage. Researchers comparing Y chromosome signatures across known living male line descendants of Richard's family found inconsistencies that pointed toward at least one historical break in the paternal chain. This discrepancy ignited a storm of speculation about when such a break might have occurred and what political implications it could have carried at the time. The DNA did not name the generation where the divergence had happened, but it confirmed that somewhere in the paternal ancestry, an unrecorded event had altered the biological line. Such a discovery shook the foundations of royal genealogy, suggesting that the careful construction of dynastic succession had, at some point, been unknowingly disrupted. The implications rippled through historical interpretations of monarchy, casting new light on how legitimacy had been determined, challenged, and manipulated. The genome also provided insights into the environmental conditions Richard endured. Medieval life, especially for someone raised during periods of civil conflict, involved exposure to heavy metals, pathogens, and nutritional challenges. DNA methylation patterns and other molecular markers hinted at environmental stressors that left lasting imprints on his biology. Traces consistent with periods of elevated stress, likely corresponding to major political upheavals or military campaigns, remained etched into his genetic profile. These findings captivated researchers because they offered a rare biological window into the lived experiences of a medieval king, revealing that his body had recorded the pressures of leadership, warfare, and rapid shifts in fortune. Scholars emphasize that this fusion of archaeology and molecular biology allowed a more intimate understanding of medieval life than written sources alone could provide. Another remarkable discovery involved the presence of genetic markers associated with resistance to certain diseases that were rampant during the medieval period. These markers suggested an inherited resilience that may have contributed to Richard's survival through adolescence and young adulthood, when infections and epidemics frequently claimed lives. The analysis identified variations associated with improved immune responses to some viral and bacterial pathogens, offering a biological explanation for why Richard had endured epidemics that swept through England during his lifetime. These markers also indicated that natural selection had shaped his ancestry through generations of exposure to widespread medieval illnesses. Such findings emphasize the complex interplay between heredity and historical context, demonstrating how the biological legacy of ancestors equipped their descendants to navigate the perils of their time. Equally compelling were indications of genetic predispositions towards certain nutritional sensitivities and metabolic patterns. Medieval diets differed substantially between social classes, and the rich, while having access to plentiful food, often consumed meals that were heavy in meat, sugar, and alcohol. These dietary habits could contribute to long-term health issues. Genetic analysis suggested that Richard's metabolism may not have been ideally suited to the aristocratic diet of his era, potentially burdening him with vulnerabilities that compounded over time. These insights prompted scholars to reevaluate the health challenges faced by medieval nobility, challenging the assumption that wealth and status automatically conferred superior health outcomes. Instead, the genome showed that inherited biological traits intersected with dietary customs in ways that shaped the health of even the most privileged individuals. The genetic evidence also illuminated migration patterns that had influenced the shaping of Richard's ancestry. Markers common among populations in certain regions of Europe indicated historical movements that had blended diverse genetic influences into the English royal line. These findings suggested that the royal ancestry had been shaped not solely by English or Norman heritage, but by deeper and more varied continental currents. This realization prompted historians to revisit assumptions about medieval identity, culture, and politics. The DNA demonstrated that the boundaries modern societies imagine were far more permeable in the medieval world. Families, including those destined for royal roles, were shaped by interactions across borders that were often fluid, shifting, and interconnected. Researchers also uncovered clues about Richard's microbiome at the time of his death. Although only fragmentary traces remained, the analysis hinted at the types of bacteria that had inhabited his body, offering insight into his general health, diet, and environmental exposure. These microbial signatures, though incomplete, revealed patterns consistent with a lifestyle involving frequent travel, exposure to varied environments, and a diet reflective of both aristocratic privilege and the logistical necessities of military life. Such pioneering research pushed the boundaries of what science could uncover from centuries-old remains, demonstrating the power of modern molecular techniques to reconstruct aspects of daily living that once seemed irretrievable. The implications of the genetic analysis extended beyond Richard himself. By exposing the complexities and uncertainties in royal lineage, the findings challenged society's deeply ingrained reliance on hereditary authority. The very notion of royal legitimacy had been built upon the presumption of verifiable bloodlines linking rulers to ancestors deemed worthy of the throne. The DNA results emphasize that such lines were far more fragile and open to disruption than historical narratives had allowed. This raised profound questions about how kingdoms had been justified, governed, and inherited. The discovery prompted renewed scrutiny of how political power was constructed and maintained through biological claims that may not have matched biological realities. Scholars began to reassess dynastic histories with fresh skepticism, recognizing that political stability had often rested on assumptions rather than incontrovertible truths. At the same time, the genetic analysis highlighted the extraordinary vulnerability of historical narratives that had long been accepted as fact. Written sources, while invaluable, had been shaped by political agendas, personal biases, and incomplete perspectives. DNA offered an independent lens through which to examine the past, often confirming some historical accounts while contradicting others. In Richard's case, it provided clarity on aspects that had been distorted through centuries of propaganda and dramatization. This strengthened the role of interdisciplinary research in historical scholarship, demonstrating that science could complement and refine the stories preserved in texts, artifacts, and oral traditions. The revelations also sparked conversations about identity, both personal and collective. For centuries, Richard III had been one of the most controversial figures in English history. His reputation had fluctuated dramatically, influenced by the political climate of subsequent monarchs, interpretations by historians, and fictional portrayals that molded public perception. DNA allowed researchers to move beyond such cultural constructions by grounding Richard's identity in biological reality. The genome revealed his vulnerabilities, strengths, and inherited traits in ways that transcended ideological portrayals. This scientific perspective encouraged a more empathetic understanding of historical figures, reminding society that beneath the layers of myth and political interpretation stood individuals shaped by the same biological forces that influence people today. Another dimension of the findings involved the role of technology in transforming historical research. The ability to extract viable DNA from centuries-old remains represented a monumental leap in scientific capability. By applying advanced sequencing methods, scientists transformed bones, once considered silent relics, into sources of rich biological data. This breakthrough demonstrated the potential for unlocking insights from other historical remains, promising a future where genetics plays a central role in reconstructing human history. The analysis of Richard's DNA became a case study showing how science could bridge the gap between past and present, enabling scholars to ask questions that were once unimaginable. The impact on medieval studies was profound. The genetic findings compelled historians to revisit assumptions about royal marriages, succession disputes, and family alliances. Many political conflicts of the period had hinged on claims of legitimate descent, yet the DNA suggested that such claims were not always biologically precise. This realization illuminated the human complexities behind dynastic struggles, revealing how personal choices, hidden relationships, and political necessities had shaped the course of history. The genome suggested that beneath the polished rhetoric of royal documents lay a world of secrets, uncertainties, and unexpected connections that had influenced outcomes just as powerfully as battles and treaties. The analysis also revitalized interest in the social and cultural dimensions of medieval life. By uncovering details about Richard's ancestry, health, and environmental experiences, the DNA offered a lens through which to explore the broader conditions of the era. Scientists and historians collaborated to piece together a more comprehensive understanding of medieval society, recognizing that the experiences of a king could illuminate broader societal patterns. Richard's genome became a focal point for discussions about class, mobility, nutrition, disease, and environmental exposure in a period often shrouded in myth. Moreover, the findings inspired discussions about the relationship between science and memory. Richard III had been remembered through a mixture of historical accounts, literary portrayals, and cultural narratives. The genome introduced a new form of remembrance, one rooted in biological reality rather than textual tradition. This blending of scientific data with historical memory demonstrated the evolving ways in which societies engage with their past. It showed that memory is not fixed, but continually reshaped by new discoveries that challenge established interpretations. The revelations embedded in Richard III's DNA also encouraged a deeper appreciation for the fragility of life in the medieval world. The genetic markers associated with disease resistance, juxtaposed with those indicating vulnerability, highlighted the precarious balance of health that defined the era. Even a king, despite wealth and power, was subject to the same biological risks as ordinary people. This underscored the shared humanity between rulers and subjects, challenging the notion that nobility existed in a sphere apart from the populace. The genome reminded researchers that biology knows no hierarchy and that the powerful are equally shaped by inherited traits and environmental forces. The unprecedented depth of information drawn from Richard III's DNA inspired researchers to probe even more obscure corners of medieval biology, pushing the boundaries of what could be inferred from ancient genetic material. One area that captured their attention involved subtle markers associated with psychological predispositions. Although genetics cannot define personality, certain variants offered hints about neurological tendencies that may have shaped Richard's temperament. Patterns linked to heightened stress sensitivity were detected, suggesting he may have been biologically inclined toward intensified emotional responses during moments of pressure. This did not define his decisions, but it provided a biological framework that could have interacted with the tumultuous circumstances of his life. Such findings allowed scholars to construct a more holistic view of medieval kingship, recognizing the interplay between inherited traits and the immense responsibilities placed upon those thrust into leadership. Another aspect that emerged from deeper genetic scrutiny involved Richard's developmental history. Epigenetic marks preserved in his remains hinted at periods during his childhood when nutritional availability may have fluctuated. These molecular traces indicated phases where his body had adapted to inconsistent calorie intake, even within the relative privilege of a noble household. Historians recognize that despite noble status, political unrest, seasonal famines, and disruptions in supply chains could affect even royal children. The DNA evidence supported the idea that Richard's early years were influenced by broader societal instability, shaping his physical development in ways that textual sources had never fully conveyed. Such discoveries enriched the understanding of how medieval conditions impacted individuals across all social strata, revealing that biology preserved memories of hardship long after written accounts had faded. The analysis also began illuminating Richard's sensory biology. Certain genetic variants suggested heightened sensitivity to particular tastes and smells, traits that could have influenced his preferences and habits in daily life. Medieval cuisine relied heavily on preserved foods, strong spices, and ale, meaning sensory perception played a significant role in dietary choices. Scientists theorize that Richard may have preferred certain dishes not merely out of cultural convention, but due to his biological predispositions. This opened new pathways for exploring how sensory genetics shaped the lived experiences of historical figures, adding another layer of dimension to their personal worlds. Moreover, researchers identified genetic clues related to circadian rhythms, implying that Richard may have naturally leaned toward specific sleep patterns. In a time when artificial lighting was limited and rulers often operated according to the demands of court, warfare, and diplomacy, inherent biological inclinations could subtly influence behavior. Variants suggesting earlier waking tendencies pointed to a natural alignment with the rhythms of medieval governance, where dawn often marked the beginning of administrative and military activities. Such findings encouraged historians to reconsider assumptions about daily life in royal households, recognizing the fundamental role of natural biological schedules in shaping routines. Additional examination uncovered complex interactions between Richard's genetic profile and the environmental chemistry of the medieval period. Traces of heavy metals embedded in his remains, combined with genetic variants affecting detoxification pathways, hinted at how his body processed the polluted environments common in urban centers and battlefields. Medieval cities often contained elevated levels of lead from pottery glazes, water pipes, and construction materials. The DNA suggested that while Richard had some capacity to metabolize environmental toxins, his body likely contended with a cumulative burden over time. This revelation highlighted the pervasive impact of environmental hazards on medieval populations, even among the elite, and emphasized the importance of integrating biological evidence into historical studies of living conditions. Investigators also explored genetic signals tied to cardiovascular health. Though skeletal remains do not preserve soft tissues, the genome offered glimpses into potential vulnerabilities that might have influenced long-term well-being. Variants associated with blood circulation efficiency and heart function hinted at predispositions that, when combined with the physical demands of military life, could have shaped Richard's endurance and physical resilience. The insights reinforced the notion that rulers, for all their symbolic power, remained subject to the same biological constraints as their subjects. The sequencing further revealed genetic connections to regions beyond those traditionally associated with the English royal family. Subtle mitochondrial signatures pointed toward ancient maternal ancestry, extending deeper into European and possibly Near Eastern populations. These findings underscored the complexity of population movements across centuries and highlighted how noble lineages intersected with far older migrations. The discovery encouraged historians to reimagine medieval identity not as an isolated phenomenon, but as the culmination of countless ancestral journeys that transcended borders and eras. As researchers continued analyzing the genome, they uncovered markers associated with physical endurance, suggesting that Richard possessed natural traits supporting prolonged periods of activity. Medieval kings who participated in battle needed exceptional stamina, and these genetic hints provided insight into how Richard might have met the demands of campaign life. They painted a picture of a ruler whose biological foundation equipped him for the physically grueling expectations of leadership in a turbulent age. If you liked this video, please give it a like and subscribe to our channel. Also, leave your comments below and tell us, what are your thoughts on DNA results? We want to hear from you. Thank you for watching, and see you next time.